What if I told you that right at this moment you are resting inside an empty pit? A pit so massive that even light would take 1 billion years to cross it, and this isn't science fiction. Over the last 2 years, scientists have been gradually confirming that our own Milky Way galaxy, our solar system within it, and our Earth within that, are all resting inside a gigantic empty region. And the mind-bending part is that the discrepancy scientists had been seeing in the universe's expansion for the last 10 years wasn't actually a mistake. It was us. We are slowly drifting out of that pit, and because of this gentle drift, all of cosmology was caught in a paradox that had remained unsolved until today. But this is only the beginning, because there is another place in the universe, 700 million light-years away from us, where there is a single galaxy, completely alone. There is nothing around it for 100 million light-years, and the ESA, or European Space Agency, said that if our Milky Way were in that position, we wouldn't have even realized that other galaxies exist in the universe until the 1960s. We would have believed that we were the entire universe. Today, we will quietly explore the universe's largest empty deserts, the cosmic voids, and a specific void named the Buddha's Void, along with a fascinating truth, that we too are resting inside a similar void and didn't even know it. So, settle in, get comfortable, and let your thoughts drift as we begin. The story begins in 1981 at Harvard University. There was a scientist named Robert Kirshner. He and his team started a task that seemed very minor at the time. They wanted to create a 3D map of galaxies. I mean, when we imagine the night sky, it appears like a flat picture. We don't immediately know which galaxy is close and which is far away. So Kirshner's team thought that if they could calculate the distance to every galaxy, they could create a proper 3D map of the universe. They started looking in a specific direction. There was a constellation in the sky called Bootes, and they began calculating the distance to every galaxy in that direction. They kept collecting data from thousands of galaxies, one after another. Then one day, they plotted their data, and what they found was something no one had expected: a gigantic hole. A completely empty space where there should have been thousands of galaxies. There was nothing there. Kirshner and his team thought there must have been some mistake. Perhaps their telescope wasn't working properly. Perhaps they hadn't surveyed that area thoroughly. They checked again, then a third time, but every time the answer was the same: there was nothing there. When they published their paper, they titled it 1 million empty cubic megaparsecs in Bootes. And do you know what the most interesting part is? They placed a question mark at the end of the title because they themselves couldn't believe that such a massive empty space could be real. But it was real. The diameter of the Buddha's Void was 330 million light-years, an empty space that accounts for 0.27% of our observable universe. Just imagine how enormous that is. If light, the fastest thing in the universe, tried to travel from one side of this void to the other, it would take 330 million years. That means, when light would have begun this journey, even dinosaurs had not yet evolved on Earth. But the real question is, how can such a massive empty space form? Is empty space common throughout the universe? Or is the Bootes Void an exception? To understand the answer, it helps to understand the structure of the universe itself. You might imagine the universe as something uniform equal. Galaxies, equal stars, and equal amounts of matter everywhere. But that picture is not accurate. The universe actually resembles a vast web, almost like an enormous spider web. There are delicate filaments stretching in every direction, and between these filaments lie gigantic empty spaces. Galaxies rest upon these filaments, almost like tiny drops of water on a web. Scientists call this remarkable structure the cosmic web. And perhaps the most surprising thing about this web is that, in terms of volume, most of the universe is empty. The filaments are only thin strands. Everything else is a void. This means that if you were to choose a random direction and point anywhere in the universe, the chances are greater that you would be pointing into a vast, silent void, rather than toward a galaxy. But there is an interesting question that naturally follows. If the universe is mostly empty, then just how empty are the voids we discover? Are they completely empty? Or is there still something hidden within them? This is where one of the most haunting facts about the Boötes Void comes into view. The Boötes Void is not completely empty. There are a few galaxies inside it, but only a handful. To date, scientists have discovered only 60 galaxies within that enormous void. In a typical region of the same size, there should have been thousands of galaxies. This means that what exists inside the Boötes Void experiences a level of isolation almost beyond imagination. Among those 60 galaxies, there is one that scientists have given a special place in their discussions. Its scientific name is MCG 10.120215, but it is more widely known by another name, the loneliest galaxy in the universe. It is a spiral galaxy, very much like our own Milky Way. Yet there is nothing around it for 100 million light-years. No neighboring galaxy, no cluster, no filament, only an immense stretch of darkness. Pause for a moment and imagine what that truly means. Our own Milky Way has Andromeda nearby, only about 2.5 million light-years away, and dozens of smaller galaxies surround us as well. The universe around us is filled with galaxies. Human eyes simply are not sensitive enough to see them without powerful instruments. With a sufficiently capable telescope, almost any direction reveals another distant galaxy. But for MCG 10.120215, even if an advanced civilization lived there and possessed telescopes just as powerful as ours, they would still find almost nothing beyond their own home. Only vast darkness, stretching in every direction. The European Space Agency once made a statement about this, and it is a thought that lingers in the mind. They explained that if our Milky Way had existed in such a location, humanity would not have realized that other galaxies existed until around the 1960s. We would have believed that the Milky Way was the entire universe. Imagine living in that alternate reality. Ancient civilizations, looking into the night sky, would have seen only the stars of their own galaxy, while everything beyond would have remained dark and silent. Their philosophy, their beliefs, and their understanding of nature would all have grown from the assumption that they were completely alone in existence. And for them, that conclusion would have seemed perfectly reasonable. In many ways, we have been fortunate. We live in a region where other galaxies surround us. About a century ago, through the work of Edwin Hubble, humanity discovered that our galaxy is only one among countless others, and from that realization, we built an entirely new understanding of the universe. But now, another remarkable question appears. Are we really as surrounded as we have always believed? In 2013, 3 scientists, Keenan, Barger, and Cowie, published a paper after studying the galaxies around Earth in a different way. They observed the universe through infrared light because infrared wavelengths pass through cosmic dust far more effectively. What they discovered was surprising. Within a radius of approximately 1 billion light-years around us, the density of galaxies is about 20% lower than the average density found elsewhere in the universe. In other words, we also appear to be living inside a cosmic void. This region is known as the KBC Void, named after those 3 scientists. Some researchers also refer to it as the local hole, while others call it the Hubble bubble. Its radius is approximately 1 billion light-years, making it even larger than the Boötes Void. And according to this idea, we are located very close to its center. At first, that might not seem especially important. After all, life continues exactly as it always has. But this is where the story becomes truly fascinating. For the last decade, scientists have been trying to solve one of the greatest mysteries in modern cosmology, a puzzle known as the Hubble tension. Think of it this way. Astronomers measure the rate at which the universe expands. That rate is called the Hubble constant, named after Edwin Hubble, and it can be measured in 2 different ways. The first method involves observing nearby supernovae. By studying the light from exploding stars and galaxies close to us, scientists can calculate both distance and velocity. The second method studies the cosmic microwave background, often called the afterglow of the Big Bang. By measuring that ancient light, scientists can determine how rapidly the universe was expanding shortly after its beginning, and calculate how rapidly it should be expanding today. Both methods should arrive at the same answer. Yet they do not. Measurements based on nearby supernovae suggest that the universe is expanding faster. Measurements based on the cosmic microwave background indicate a slower expansion. The difference is far too large to dismiss as ordinary measurement error, because both techniques are remarkably precise. So how could such a contradiction exist? For nearly 10 years, scientists searched for an explanation. Some proposed that our understanding of physics might be incomplete. Others suggested that dark energy could be changing over time. Still others wondered whether an entirely unknown force might be influencing the universe. Yet none of those ideas produced a definitive solution. Then, in July 2025, during the Royal Astronomical Society's National Astronomy meeting, a scientist named Indranil Banik presented a paper that offered a striking possibility. Banik argued that the Hubble tension may not be a true tension at all. Instead, it could simply be the result of where our own galaxy happens to be located within the universe. Think of it this way. Imagine that we are living inside a vast cosmic void, while much denser regions exist beyond its boundaries. Gravity naturally pulls toward those denser regions. As a result, everything inside the void, including our own Milky Way, is being gently drawn toward its outer edges. In other words, our galaxy is slowly drifting outward, moving away from the emptiest part of the void and toward regions where more matter exists. That gradual motion has an important effect on the way we measure the universe. When astronomers observe the light from nearby supernovae, they usually assume that those galaxies are moving away only because the universe itself is expanding. But in reality, two motions are taking place at the same time. One is the expansion of the universe itself. The other is our own slow movement outward from the void. When those two motions are combined, the speed we measure appears slightly higher than the true rate of cosmic expansion. For many years, we believed that the universe was expanding at that faster rate, but perhaps what we were really detecting was our own gentle drift through space. The method that uses the cosmic microwave background tells a different story, because it measures the distant universe on scales so vast that our local motion has almost no influence. As a result, that method produces a different value. If this explanation is correct, then the Hubble tension that puzzled astronomers for the past decade may not have been a flaw in physics at all. It may simply have been a blind spot created by our own location. We were living inside a cosmic void without realizing it, and our position subtly influenced the way we interpreted the expansion of the universe. It is a remarkable possibility, and the implications reach even further. If we truly live inside a void roughly 1 billion light-years across, then our understanding of the universe may look slightly different from the perspective of observers living elsewhere. Imagine a civilization in a region with an average cosmic density far beyond a void like Bhuta's. Their measurements of the universe's expansion could differ from ours, and they might never encounter the same tension that has challenged modern cosmology. It raises a fascinating thought. Perhaps some of the universal truths we have uncovered over the past century are also shaped in subtle ways by the place from which we observe the universe. That naturally leads to another question. If we are inside a void, and if many other enormous voids exist throughout the cosmos, then how did these immense empty regions come into existence? How did parts of the universe become so incredibly empty? According to our current understanding, immediately after the Big Bang, the universe was remarkably uniform, though not perfectly so. Tiny differences in density already existed. Some regions contained just a little more matter, while others contained a little less. Those incredibly small differences are thought to have originated from quantum fluctuations, minute ripples present during the universe's earliest moments. Then gravity slowly began shaping everything. Regions containing slightly more matter attracted even more material, becoming denser over time. Regions containing slightly less matter gradually lost material as gravity pulled it away toward denser areas. Over billions of years, This simple process continued. Dense regions became even denser. Galaxies formed within them. Then, galaxy clusters appeared, followed by enormous superclusters. Meanwhile, the emptier regions continued losing matter until they became the immense cosmic voids we observe today. The vast cosmic web emerged from those tiny differences. Structures such as the Bhutas void and the KBC void may both be the result of incredibly small imbalances present just after the Big Bang, with those minute quantum fluctuations growing for 13.8 billion years into the largest structures in the observable universe. Perhaps the most fascinating part is that this process has not stopped. Cosmic voids continue to evolve. Galaxies slowly drift away from them, and in many ways, we are part of that same long and gentle journey through space. At the very beginning, I said that we are living inside an enormous empty pit. Now you know that this idea may be more literal than it first sounded. And if current research is correct, then we are also slowly moving outward from that pit, carried toward its edges over immense stretches of time. That quiet motion may even have influenced one of the greatest mysteries in modern cosmology for an entire decade. The next time you look into the night sky, remember that what appears empty is often far more complex than it seems. And what appears full may not represent the whole picture either. Our place in the universe, our galaxy, and even the way we observe the cosmos may all be shaped by the enormous void surrounding us. It is a gentle reminder that the universe still holds mysteries capable of changing the way we understand everything. As this thought settles in, you might enjoy imagining what lies beyond the edges of such a void. What would the universe look like from there? And how might our picture of the cosmos change if, over unimaginable spans of time, our galaxy eventually reached those denser regions? Those are questions that continue to inspire astronomers, and perhaps one day, future discoveries will bring us even closer to the answers. For now, simply let your mind wander through the vastness of space, where even the quietest regions have stories to tell, and where every new discovery reminds us just how much there is still left to explore.